This is the Arduino starter kit, and it contains many things. The Arduino is a great way to introduce you into electronics, programming, and engineering. And if you're an engineering student like me, then you were forcibly coerced to fork over $100 for this kit at the expense of being immediately expelled from the engineering program. This cheap, flimsy box that falls apart when you merely stare at it with ambitious intentions contains many things, including but not limited to an Arduino microcontroller, a bunch of components, and a single bag filled to the brim with a complete, unorganized, hideous mess of assorted knickknacks because the manufacturers could not be bothered to neatly sort them into individual static shielding bags, because they know that if you're purchasing this product, you're either a person with crippling OCD who will neatly organize everything anyway, or you'll just stuff everything back to the box with careless ignorance like the little slob you are. This particular iteration of this kit comes with an Arduino Uno R3 microcontroller, an LCD screen, a DC motor, a servo motor, and multiple ways to power your microcontroller. It uses a breadboard to connect all your components together, so no soldering needed. And it also comes with this adorable little platform to house your projects. And these cute little cardboard graphics that you can use along with the projects book to decorate your Arduino. That unfortunately never fit properly and come out looking like crap. The aforementioned big bag of bullshit contains tons of different little electrical components like a tilt sensor, a temp sensor, light sensors, LEDs, piezo capsule, transistors, resistors, jumper wires, and so much more. What's this piece here? Well, it may look like a knob, but it's actually a potentiometer. What's a potentiometer, you may ask? Well, it's basically a knob. Nothing's labeled and everything looks similar to each other. Why? Well, because you want to be an engineer, right? You can figure it out yourself. Fuck! It also requires a computer so you can download their software so you can program the microcontroller. From what I've read and seen, the programming language is basically C++, but with a few changes to help streamline coding the microcontroller. No prior knowledge is needed in programming. The little starter book gives you everything you need to program the included projects. Speaking of which, the Fun Little Projects book contains 15 fun little projects to help ease your way into this newfound world you have just entered. Each project increases in complexity and walks you through all the steps from building your circuit to writing the code. You start by lighting a simple LED and end with using your Arduino to control external devices. Once you get through the book, you can continue your journey and make more impressive things through Arduino's online project hub, or through other online resources. And of course, there's nothing stopping you from experimenting and creating your own thing. That's the beautiful thing about free will, doing whatever the hell you want. For example, you can impress all of your fellow passengers on your next flight by standing up, yelling for everyone's attention, and showing off the beautiful ticking alarm clock you made. And if you notice that the people around you suddenly jump out of their seats and start sprinting at you, well then that means that they're just so excited to get a closer look at your beautiful creation and want to congratulate you with a job well done. These are merely memes meant for entertainment purposes. I do not promote or support these acts. Please do not do this, as this is highly illegal and stupid, and please don't put me on the FBI watch list. And if I'm already on the FBI watch list for the unrelated fortune cookie incident, then please take me off said watch list. Playing around with microcontrollers like this is one of the best and earliest parts of your engineering journey. It also lures you into a false sense of security, misleading you into thinking that you're going to be doing and creating amazing things, and making incredible contributions to society, before you get slammed with multivariable calculus, leading you to ruminate on all your major life decisions that led you up to this point, and ultimately makes you rethink your entire future, because, hey, you can always switch to a business major.
Whoa, this guy stinks!
The walk of shame for any STEM major. This is Gaming Channel, so let's talk about game. For my intro to engineering class, we had to build a little game as part of our final project. So we decided to build the stacker game. You know, the one you've seen at your local arcade where you have blocks going back and forth, and you have to stack them all the way to the top to win. But as you keep getting higher and higher, they get faster and faster, and eventually you get to that last block right before you win the grand prize, and it's going super fast now, but you've trained for this moment your whole life. You're at the top of the leaderboards in Mortal Kombat. You speedrun Super Meat Boy Deathless. You 100% through Fire in the Flames and Guitar Hero on Expert. Your hand-eye coordination, unmatchable. You, undefeatable. But then you realize that arcade games are rigged, and it snags defeat at the jaws of victory. Because you're not allowed to have nice things. It's really cool, and amazingly, it actually works. We made it look really nice. We 3D printed an arcade cabinet case that we stuffed the Arduino into, and we made some cool custom decals. And it looked very cute. Unfortunately, I don't have the finished project with me. One of the other members in our group, they used their Arduino to do the project, so rightfully they got to take the project home once we finished it. But I do have a copy of it right here. So it's like the stacker game you see at the arcade, but there are only 4 stacks of this on a 3x4 grid. To play, you stop the first LED wherever you want. From there, it goes to the next row. The LEDs flash back and forth a little faster, and now you have to stop the LED right above where you stopped the first one. If you do, it goes to the next row. You stack all 4 LEDs, you win, and it plays a happy tone. If you don't stack the LEDs, you immediately lose, it plays a sad tone, and you automatically go back to the beginning and have to start again. So, how does it work? Well, each LED is attached to one of the digital outputs on the Arduino, of which there are a limited amount of them on the Uno, so that actually limited us to how big we could actually build the stacker game. As a matter of fact, we actually ran out of digital outputs and had to start using analog inputs instead, which thankfully the Arduino allows. So each LED is connected from an output or input on the microcontroller, which also acts as its positive connection. Then each LED is connected to a 220 ohm resistor and then connected to ground. It's operated with a single push button on the bottom, and there is the piezo on the top. Again, the piezo and push button are also connected to a digital or analog pin on the Arduino, acting as the positive connection, and then of course are also connected to ground. The push button has a 220 ohm resistor, the piezo does not have a resistor. It looks like a big mess, but it's actually really simple. Since this was our very first engineering class and our first time programming anything, no one in our group had any prior coding experience, aside from the few little Arduino projects that came in the starter book that we did in class. Subsequently, the hardest part of this project was programming our game. We did figure it out eventually, but it wasn't without faults. So one issue that we ran into is that we wanted the lights to cycle back and forth. First from left to right, and then back again from right to left, like in the real stacker game. We tried really hard, but we couldn't get this to work without the game working properly. You see, at first the game allowed the user to stack lights in different columns and kept giving false wins. It had something to do with how the LEDs were being counted. When the LEDs flashed from left to right, the game would count the LEDs and assign them a value from 0 to 2. When the game starts counting those LEDs in the reverse direction, from right to left, it's supposed to start counting from 2 and then go back down to 0. But a fault in the code started to count the rightmost LED from 1, down to 0 at the center LED, and then back up to 1 at the left LED, then to 2 again at the center LED, and then to 1, and so on. The way the game works is that when you press the button and stop on an LED, it stores that value and moves you up to the next row. Then when you press that button again and stop on the next LED, it compares the value of that LED to the one in the previous row. If those two values match, then you continue playing. If the values do not match, then you lose and start over. If the game functioned properly, then each of these values would all properly align in a single column. But it doesn't work, and these values are all over the place, allowing you to get false matches, or even failing you if you matched correctly. But no matter what we tried, we could not get the game to work properly. We just did not have the knowledge or expertise to solve this problem at this stage in our educational journey. So you know what we did? We decided to remove the part of the code that makes the LEDs cycle in the reverse direction, forcing the LEDs to cycle in only one direction from left to right, and then we pretended like we wanted it to work that way all along and called it a feature, just like real engineers. What can I really say about the Arduino? I don't know. I got nothing to really compare it to. This is my first microcontroller. It works, and I've had a lot of fun messing around with it. There are cheaper, similar kits online. There are other microcontrollers out there. I don't really know anything about them, but a kit like this is a great way to get into electronics, programming, and engineering. If you're interested in something like this, it doesn't matter what you get, as long as it isn't cheap crap that ignites your house on fire, but does ignite that passion within you to create. I first got this kit when I started going back to college last year. I wish I had done it a lot sooner. It's truly a shame that only now am I starting to pursue my passions in life, but one thing I've learned is that it's never too late to start chasing your dreams. This is not a sponsored video, not by Arduino, not by Happy Mug either.
I love coffee, it's so good, I can't get enough of that.
I'm just bored and I really wanted to make a video and I didn't know what else to make, so here we are. I've been dealing with a lot over the past few years and I'm trying to wiggle my way back into content creation again. So if you enjoyed this and you'd like to see more content like this, then please be sure to like and subscribe. Thanks for watching. Peace. Something's not right here. Nope, of course. How could I mess this up? Calculus is a joke.